Hi, this is Mike from Learn with Mike Mossy. The video today is tips for reading questions on the AP Computer Science A exam. Okay, what do I mean by reading a question? Well, primarily I mean everything you do in preparation for answering the question before you dive into the details of the code. So that includes skimming the question, looking for important information that you want to make a note of for later, so making notes. Now, why is reading important in particular? The answering a question is an overall process of reading, analyzing, thinking, writing, and checking. Those all go into answering the question, but we're going to focus just on reading. And so why is that? Well, we're taking this big overall process and breaking it up into individual pieces, smaller pieces, so you can pay attention to one step at a time, and the overall process gets easier. One piece of advice I would give everyone is be sure you're answering the question that the test actually asks. I've tutored people who wrote beautiful code. It just happened to be not the code the question was asking. Be methodical in reading the question. You can avoid all kinds of simple errors by being methodical. You're really a smarter person when you're methodical. You're using your smarts fully. Some of the basic strategies for reading a question are, first of all, read every detail the question says, then read for what it doesn't say. What's missing, what's confusing, what are you left wondering about? Write down your questions, write down the things you're not sure of. Make a note of any time you're confused, and write down the question you would want to ask to get yourself unconfused. This way you're priming yourself to see that information when it comes up later in the test. Here's an example from the 2018 test. So this question involves reasoning about pairs of words that are represented by the following word pair class. Okay, just reading that much, I have a question. What is a word pair? Okay, it might be obvious that we need to ask that question, but I think it's really good to make your questions explicit. So let's read on and see if we get any clue. So it's declaring the word pair class. Here's the constructor. It takes the parameters first and second. Now I'm starting to think this is a pair is usually two things, so this is starting to seem pretty obvious. Returns, so then we have getters, get first and get second. Okay, so I'm pretty sure that this just is a pair of strings, but I'm going to still keep open to what it might turn out to be as we read more. Okay, the question says you will implement the constructor and another method for the following word pair list class. That's the main question we're dealing with right now, the constructor. But notice this is a new class, word pair list. What do they give us here? An array list of word pairs, which is some of the main private data. Here's the constructor. They say to be implemented in part A, okay, and a method called numMatches. The question I'm left here is, how do we construct a word pair list? Notice that they say you will implement the constructor, but they're not telling us how to construct. It's important to be aware of what you don't know. You could blame yourself sometimes for not knowing things, but it's important to be aware of when they actually didn't say. It's not your fault for not knowing. More of the question. Write the constructor. This is part A of the question. The constructor takes an array of strings, words as a parameter, and initializes the instance variable all pairs to an array list of word pair objects. Okay. A word pair object consists of a word from the array paired with a word that appears later in the array. Okay, now they give us some mathy stuff. The all pairs list contains word pair objects, words I, words j for every I and j. All right, this is complicated to understand. It's not concrete, it's abstract. We're probably not going to understand it until we see a concrete example or make an example ourselves. Every word pair object is added exactly once to the list. Okay, here's an example. It might be more clear here. The words are 1, 2, and 3. After the code segment has executed, the all pairs instance variable of example1 will contain the following word pair objects in some order: 1, 2, 1, 3, and 2, 3. Now it looks like these are just all possible pairs of 1, 2, and 3. To give you a better idea what an algorithm might be for constructing all possible pairs, okay, I've repeated the example here. This is the same one you saw on the previous page. That right there, repeated right here. And I'm going to describe a way of visualizing this pattern, the jumping pattern. How do we form all possible pairs? Well, first we form all pairs that have a 1 in them. And you can see that we pair with 2, that's this short blue arrow. We pair with 3, that's the long blue arrow. Then we find all pairs with 2 in them, and that's the short red arrow. There's only one word left, so there's only one red arrow. We don't need to consider 3 at this point because we've already made pairs with every other word. This jumping pattern is a way of making the algorithm visual and physical. I'm sure you'll agree this is a lot more clear than the math language they used. Here's another example. The phrase is "the more the merrier." Okay, here's the possible, here are the pairs: the more, the merrier, more merrier, and the merrier. Okay, I'm getting a sense again that it's making all possible pairs. If we look at the jumping pattern here, we can see, and then move your eyes between the jumping pattern, like this short blue arrow, the more, and then move your eye over here and we see the corresponding pair. Okay, longer blue arrow, the, we see the, longest blue arrow, the merrier. And then you can continue this pattern. Just take a look at that. Move your eyes between the pattern and the list of words and see if you can match them all up. Okay, we'll go on. This just repeats the information for this question. I'm going to skim it here. Look at the class name word pair, the methods, class name word pair list. Okay, so in the actual test you would read this very closely. I don't see any new information here. And here's where they give you space to write the constructor. Part B of this question. Write the word pair list and num matches. This method returns the number of word pair objects in all pairs for which the two strings match. Okay, so this is starting to become pretty obvious. The following code segment creates a word pair list object. Okay, we've seen that before. Here are 5 words, so there's quite a few pairs now. They're all down here. They've highlighted for us 2 matching pairs. That's great. Okay, here's the class information for this question. Again, trust me, there is no new information here. And here's where you complete the method num matches. At this point, we're fully prepared to write the code. We've skimmed it. We've noticed details. We've written down our questions. And now we're in a better position to write the code. So to summarize, the basic strategies I want you to use are read every detail the question says, read for what it doesn't say, write down your questions, and make a note of any time you're confused. Write down the question you would want to have answered, you would want to ask. And let me leave you with, be sure you're answering the question the text actually asks. This has been Tips for Reading Questions on the AP Computer Science A exam. Thanks for watching. Be sure to like and subscribe, and I'll see you next time at Learn with Mike Mossy.